In this video, we're going to work through a free fall problem. So in this particular thing, it says a marble is dropped from a bridge, strikes the water in 5.3 seconds. Alright, so there's some marble up here. Let's say it's right here. It's at some height y, and it eventually is going to hit the water, which I will say is my y equal 0 meters. So this was y naught, which I don't know. And it's dropped with a vy naught equals 0 meters per second. And it eventually has some new speed right before it hits the water, which I don't know. And of course, we need our coordinate system. So there's x, there's y. Free fall problems are constant acceleration problems involving kinematic equations, so we want to build our table. Y naught, I don't know what that is. Y, I've chosen that to be my 0 meter position. Vy naught is 0 meters per second. Final velocity at the water, I don't know. Acceleration in y is minus g, which is minus 9.8 meters per second squared based on what I've put my coordinate system, and time is 5.3 seconds. Physics, free fall. I know the kinematic equations are true. Y is y naught plus vy naught t plus 1/2 ayt squared. Vy naught is equal, I'm sorry, back, my fault, plus ayt, and vy squared is the initial speed squared, plus 2 ay y minus y naught. And of course I'm going to want to simplify those in whatever ways I can. I can simplify this as 0. I know this is 0. This is 0. This is 0. And this is 0. Notice the fact that this was dropped, implying no initial speed along the y direction, was huge because it enabled us to greatly simplify these equations. Now I know the time, I know the acceleration, I could tell you how fast it was traveling at the bottom. If I knew how fast it was going and I put it in here, I could even work back how tall the bridge was. The question is, there's really two things that you want to know. There's three equations. Let's see what we're being asked. It says calculate the speed with which the ball strikes the water. So the first thing they're asking in A is to find Vy. And because they're saying speed, they only want the magnitude, so they don't care about the minus sign. It will be going in the negative direction. It will have a negative value because it's a velocity component. All right, but they're saying speed, so they're only wanting the magnitude of the number we come up with. So they're wanting the absolute value of Vy. And then in part B, they're asking you for the height of the bridge. And so, like I've said before, if you've really written this thing down and you've really set it up properly, you should be able to just scroll that off, and with nothing but what you've written in your table, you should be able to solve those problems. So I'm going to do that. And I'm going to remind that our goal is A, find the absolute value of Vy. That's what I want to do. Now, looking at this, I see this equation doesn't have Vy, so it wouldn't be my first choice. This one does. Do I know Vy? No, I'm looking for it. Do I know Ay? Yes, I do. Do I know T? Yes, I do. Hey, plug and chug. This one is very quick. Vy is equal to minus gt, which is minus 9.8 meters per second squared times 5.3 seconds. Vy is approximately, when you plug all that in, minus 51.9 meters per second. So the absolute value of Vy, which is the speed, is therefore 51.9 meters per second. So that's the answer to problem part A. Let's look at part B. Part B is asking for why not? How tall the bridge is. Well, why not is in this equation, so that's a possibility. It's in that equation. Now I could work in this problem because I now know Vy down here, in particular that formula, and if I put that formula in and work it, it'll work out. I also have it up here. Why not? I know 1/2, I know Ay, I know t squared, so I could solve that equation. Turns out if you plug a number in here for this equation and try to solve for why not in this equation, you plug this in, then you're plugging in rounding. If you're going to plug in, you really want to plug in the formula into here. Now, with modern calculators, and if you don't do very many calculations as simple problems in a homework or class, that error won't be much. But if you're doing it in the real world, as you go on, it will become greater. And so this is just good habits like learning to breathe that you need to get into. Okay? Either way, if you plug the formula in here, you'll end up with the same exact formula that you get if you do it up here. So it won't really matter. That's because, obviously, there's only one correct way, or one formula, if you would, that gets the right answer for calculating why not. So I'm going to take the second way. I'm going to just take the formula that we have up here, and I'm going to solve that for why not. So why not is equal to minus 1/2 Ayt squared. But Ay is minus g, so I have a minus 1/2 times minus g t squared. So the height is 1/2 g t squared. Now g is about nearly 10, so you get one of the fundamental rule of thumbs. If you drop a ball, the distance it travels is roughly 5 times t squared, where t is in seconds and y is in meters. So if you drop it 1 second, it'll fall 5 meters. All right, roughly a little more than 5 yards. If you throw it 2 seconds, it'll do 4 times 5, or about 20 meters. All right, gives you a rough rule of thumb about how far a ball talks. So if you dropped a ball off the top of a building, you could roughly, by measuring the time, determine the height of the building. Let's put this in here. 1/2, 9.8 meters per second squared. This thing was dropped 5.3 seconds. So that's about 25 times 5, or about 125 meters. And if we actually plug it in, we find it's a little more than that. It's 138 meters. Again, should always get a rough estimate before you punch numbers in a calculator. 138 meters, that's more than a football field high. So, that's a tall bridge, like you would expect. Anyway, that's the end of this problem.